Hello and welcome back, everybody. Today in geometry, we will be closing in into the end of chapters 9, and we're going to, I guess, conclude all the stuff that we can say about certain types of quadrilateral. And then tomorrow, or actually the next section, will be something else then, okay? All right, so here, as we said, we're going to go ahead and define a few more quadrilaterals for you guys. And these are terminologies that you guys might be familiar with, but we're now going to go ahead and give them formal definitions. So here they are. We're going to look at the rhombus, a rectangle, and also a square. So to go by a formal definition, we first say that if you have a quadrilateral ABCD, a rhombus is defined as any parallelogram, and because remember, parallelogram is a quadrilateral, that has four sides that are going to be congruent to each other. So, just to kind of draw a picture of it. So if you have, like, say, the following here, let me just go ahead and draw something like this. You can see that that's going to be a rhombus because these guys all are going to be congruent to each other. In addition to that, because it's a parallelogram, then that means that certain sides are going to be parallel like this, and all of those theorems that we learned or we proved for a parallelogram is definitely going to apply over here as well. The next item is we're going to look at a rectangle, which is defined as also a parallelogram, but with this time, four angles that are going to be congruent to each other. So here, just as an illustration, once again, you can see that this would be defined as a rectangle. So these two are going to be parallel to each other, and then these two are going to be parallel to each other. Now, the one thing that's kind of weird about this is that they didn't actually say that the rectangle is going to have all four angles that are going to be right angles, because technically that's what they are. But the definition that they used in this book is that they are all four are going to be congruent. So eventually we're going to go ahead and prove that those are going to be right angles, and we can go ahead and say that, well, just go ahead and use that as a formal definition then. So then that way you don't have to use that as a theorem. But nonetheless, yes, according to what we have, that means that these guys right here are going to be congruent. And then finally, for the last one, we have a square, which is defined as, once again, a parallelogram, but this time with a combination of the rhombus and the rectangle, where all four sides and all four angles are going to be congruent then. Or if you want, simply put, you can say that it's a rectangle with all four congruent sides. Or you can even say that it's a rhombus with all four congruent angles then, okay? All right, so now we can share kind of like a small little illustration as to what's happening, just as an overview. At first, we define what is a quadrilateral, and the quadrilateral, you can see, is just something with any four sides. The first subset that we got into afterward was that we have a parallelogram. That's how we define it at the very beginning of the chapter. And then from there, we look into that subset, which will then be a rectangle. So that's kind of like a more restricting parallelogram, where you have four angles that are going to be congruent to each other. And then now, even more restricting than a rectangle is going to be a square, where all four angles are congruent and all four sides are congruent. So basically, we're kind of like, going into kind of like a subset within a subset within a subset, and so forth and so on and so on, okay? Now, in this section, we're going to go ahead and discover what are some of the things that we can say about the rectangle, the square, and also the rhombus in terms of not their sides, but rather their diagonals, because, well, we already know the stuff according to the formal definition of what's going to happen with their sides and angles. So here is what I want to do. I want to look at what kind of conclusions we can come up with about the diagonals of a parallelogram, rectangle, and a square, or technically also a rhombus. So let me just go ahead and kind of sneak that in there. Rhombus as well. Okay. Now, we did the first one already. If you have a parallelogram, the conclusion about the diagonals, as you can see that's in the red right here, is that the diagonals are going to be bisecting each other. Okay. So bisecting each other. So that is to say they basically cut each other in half, and you basically have the same midpoint for both of these guys. That doesn't necessarily mean that diagonals are going to be congruent, but they are going to have the same midpoint then. If you now change it so that the shape of the parallelogram becomes a rectangle, you'll notice that the diagonals now, according to what we have, well, the first conclusion of the parallelogram is still preserved. You can see how the diagonals are still going to be intersecting each other by their midpoint. But notice the way that it's drawn, because it is a rectangle, you can even go even further now. For a rectangle, we can say that the diagonals are going to be bisecting each other, or they're going to, what's the word? So they are going to be congruent and also bisecting. So the diagonals are bisecting each other and congruent. Okay, so notice how we can now get more and more restricting information as a result then. See, so congruent. Okay, having a hard time spelling for some reason today. Okay, in addition to that, we need to prove that again, if you have one right angle, then the rest are going to be right angle, which we'll go ahead and prove in just a little bit. And now if we go even more restricting, looking at that rectangle as a square, you can now see what's happening in this case with the diagonals. Definitely, it looks like they are going to be congruent to each other. They are going to be bisecting each other. But if you look a little bit more carefully, because this piece right here is congruent to this side, to this side, to this side, my guess is that you guys also have right angles over here. So the conclusion that we're going to try to get out of this one eventually is that the diagonals are perpendicular bisecting each other and congruent, okay, and congruent to each other, all right. And whereas the last one, which I didn't put in there because I kind of missed it by the last moment, is what if you have a rhombus, which is not as restricting as a square. You can see here that the diagonals are going to look like it's bisecting each other. They are perpendicular to each other. So the conclusion is that they are going to be perpendicular bisecting each other, but they are not congruent to each other. So that's our conclusion in this case. So the diagonals, okay, are perpendicular bisecting each other. Okay, so all of these guys right here, they're definitely going to be proofs that you're going to be doing on your homework assignment. So, looking forward to that one. And the way you prove for them, well, it's most likely going to be by some sort of congruent triangles then. All right, so let's go ahead and do some of the theorems that we're going to see in this section. The first one is, as we said, if you have a quadrilateral, which is going to be ABCD, actually a little bit more specific, if you have a parallelogram that's ABCD, and one of the angle is a right angle. So you can see that angle A is a right angle over here. Then the conclusion is that we have angle B, angle C, and angle D are right angles. So what we're trying to get to is that what we have right here is really a rectangle. And this rectangle, all the angles are supposed to be right angle. That's what we're trying to prove. The only thing that we have to work off of is that it's a parallelogram and that one of the angle is a right angle to begin with. Well, let's go ahead and see how we can actually prove this. I do believe that there was a theorem at the beginning of chapter 9 that says that, hey, if two sides are parallel to each other, right, and such that one side is perpendicular to another side, then that means that the other parallel line should also be perpendicular to that same line. So that is to say, if L1 is parallel to L2, L2 is perpendicular to L3, then the conclusion is that L3 is going to be perpendicular to L1. So from there, we can go ahead and sneak in that angle D as a right angle. Well, going by that same logic over here, right, going by that same theorem, I can go ahead and say that since D is a right angle, then C is a right angle. And if C is a right angle, then I can say that B is a right angle. So using that theorem 4 times, then we got our proof then. Or actually, I guess in 3 times in this case, okay? Okay, next, theorem 9-24. This time we're going to look at the quadrilateral as a rhombus. So if we have a quadrilateral that is a rhombus, again, meaning that all 4 sides are congruent to each other, the conclusion, as we said earlier, is that the diagonals AC and BD perpendicular bisect each other. So you can see that in blue is basically what's given. All the sides are congruent because we have a rhombus. The conclusion is that in red, what I want to prove is that those two are going to perpendicular bisect to each other. Well, now this we have to dig back to chapter 6, if I remember correctly. And there was a corollary, I think it's like 6-2.1 or 4.1 or something like that, which says that, hey, if you have this exact same setup as a kite right here, where you have AB is congruent to BC, and AD is congruent to DC, then the conclusion is that AB is going to be perpendicular bisected by BD. Okay, so by that corollary, 6-2.1, right, then we can say that AC perpendicular bisects BD. And in addition to that, if we just kind of like, rotate my picture, then we can use the same corollary, but this time to say that BD is going to perpendicular bisect AC. So using that corollary 2 times, then we basically got to our conclusion. So there we go. Now we know that these guys are going to be right angles, and these two are going to be congruent, and these two are going to be congruent. So be very careful here. This is a rhombus, so that means that AC is not necessarily congruent to BD. The two diagonals might not be the same length, okay? That only applies for if it's a square. Finally, let's look at the converse of that. Meaning, if this time we know that the diagonals of a quadrilateral over here are going to be perpendicular bisecting each other. Let me see if I can kind of sneak that in. The diagonals of ABCD perpendicular bisect each other, like it says in the picture. Then ABCD is a rhombus. So the red is what we're trying to prove. Well, this one definitely is a lot easier because looking at the structure that we have right there, we have 4 triangles that are all congruent to each other by SAS. So then we can say by corresponding parts that this guy right here is congruent to this guy, is congruent to this guy, is congruent to this side. Okay, so 4 triangles are congruent by SAS and then by CPCTC. Okay, then we can say that AD is equal to AB is equal to DC, which is equal to CB. And then by the definition of rhombus, okay, then we can say that ABCD is a rhombus, okay, because all sides are congruent. All right, well, there you go. Thank you so much for watching. I will see you guys next time. Take care. Bye-bye.